Okay, on this video, I'm going to go over how to do some questions on, actually, it's going to be more than one video, but how to do some of the questions from the last exam, exam number 2. It seems like we had trouble with lots of these, and so I want to make sure that we do understand how to do these, and then also how to write it correctly so that the problem with a lot of the questions I've been grading so far is I don't know what it is that you're trying to say. The notation that you're using is confusing, and I'm not sure what you understand. So we'll do number 1. And here, you're trying to take the limit as x goes to 2 of radical x minus radical 2 over x minus 2. And the one thing that you notice is that you get 0 over 0. So this is bad. Now notice that I put an arrow. The reason I did this is because this is scratch work. And since it's L'Hopital, or since it's the scratch work is just by plugging it in, 0 over 0 is a bad thing, so we should never write that down. Now you could use this L'Hopital, but you don't have to. So I'm going to give you 2 solutions. So the first solution is not using L'Hopital. And if you don't use L'Hopital, this will satisfy standard A1. And so the way that you do standard A1, if you still need it, is that you do the conjugate. So the conjugate of the numerator is at radical x plus 2. And so here you're multiplying the numerator out, and the denominator we're going to leave like this. So this means the limit as x goes to 2 of radical x squared plus radical x radical 2 minus radical 2 radical x minus radical 2 squared all over x minus 2 radical x plus 2. And so in this case, you'll get x. Notice that the middle terms cancel. So hopefully you know the trick so you don't have to do all this writing. You get x minus 2 over x minus 2 over radical x plus 2. And then here, this should cancel. What we mean by cancel is that it's actually the number 1, that you get a 1 in here. And so this should be the limit as x goes to 2 of 1 over radical x plus 2, which is just 1 over radical 2 plus radical 2, which is just 1 over 2 radical 2. Okay, this is the correct way to write it. Notice some of you keep forgetting to write the limit. The limit needs to be at every step. But I do want you to notice that once I plug in the 2, once it's plugged in, there's no more limit. No more limit after you plug in. And that's the correct way to write this. Okay, so if you would have done it this way, you would have satisfied standard A1. Okay, so let's do this with L'Hopital. So solution 2, L'Hopital. You can use L'Hopital because you get 0 over 0. Since you get 0 over 0, you can definitely use it. So it's the limit as x goes to 2 of radical x minus 2 over x minus 2. Here, what you have to do is you see 2 functions. You see the numerator, which is radical x minus 2, and you see the denominator, which is x minus 2. And you take the derivative of both of those. So this is going to be 1/2 x to the minus 1/2, or just 1 over 2 radical x. And g prime of x is just 1. And so L'Hopital is weird because all you have to do is take the limit as x goes to 2 and then use f prime of x over g prime of x. So in other words, you don't have to use the quotient rule, which is really, really strange. But it works, and it's always correct. So in this particular example, this would be the derivative of f is 1 over 2 radical x, and the derivative of g is 1. So this is all you have to write. And so you're just taking the limit as x goes to 2 of 1 over 2 radical x. And here you plug in the 2 for x. And so once you plug in the 2, you don't need that limit anymore. You get 1 over 2 radical 2. And notice that my answer here matches my answer here. And if you do use L'Hopital, then this is standard A3, I believe I lost it. A2, standard A2, sorry. And so those are the two ways. So you can only get one of the standards. So you have to make a choice. Which one do you want to do it? Do you want to do standard A1 or do you want to do standard A2? And so that's the only thing that is different really about these two approaches. And so that should hopefully help. Now I'm going to try number two. Number two is another one that you can do in two different ways. So let me do standard A1 first, so no L'Hopital. So in this one, you have the limit as h goes to 0 of x plus h squared minus 2x plus h plus, sorry, minus x squared plus 2x, I think. Let me double check. Yep. All over h. And so on this one, again, if you plug in the h equals 0, so if you plug in the h equals 0, many of you notice that what you would get, and I'm going to do, again, this is scratch work, so it shouldn't be part of the answer. Many of you saw that you would get x squared minus 2x minus x squared plus 2x over 0. And in the numerator, you get 0, and the bottom, you get 0. So you could definitely use L'Hopital's. But again, it's not necessary because you've done these types of limits before. The limit as h goes to 0, here would be x squared plus 2x plus h squared. I'm just multiplying the first part out. Then I'm going to distribute the -2. And then there's nothing to do on the next part. And now it's just a matter of seeing if there's anything that would cancel. And so here, notice that the x squared and the negative x squared, they're gone. And that the negative 2x and the 2x are gone. And so we're left with the limit as h goes to 0. Oh, there's supposed to be an h here, sorry. Of 2xh plus h squared minus 2h over h. And then here, if you notice, the numerator has, every term has an h. So I can factor out an h, 2x plus h minus 2. Now the h's cancel. And I'm left with the limit as h goes to 0 of 2x plus h minus 2. Well, if h goes to 0 and you plug in 0 for h, this part's gone. And so you're left with 2x minus 2. Okay. So that's the standard way of doing that. That's if you want to satisfy standard A1. To satisfy the L'Hopital part, this is actually tougher. To me, at least, I think this is a harder way to do this because the variable is not x. Excuse me. The variable here, excuse me, the variable here is actually h. And the reason I know the variable is h is because h is going to 0. So here, the numerator, f of x, is x plus h squared minus 2x plus h minus x squared plus 2x. But it's not a function of x, it's a function of h. And so f prime of h would be, using the chain rule, 2x plus h minus 2, that's it. This would be 0 and this would be 0 because it doesn't have any h. And that's actually what we learned in multivariable calculus. That's why I think this is harder. And then the bottom function, the denominator, g of h, is actually just h, and the derivative with respect to h is just 1. And so if you were going to do this using L'Hopital's, which is conceptually a little bit harder, you would actually do this 2x plus h minus 1 over 1. You would plug in h equals 0, no, sorry, 2x minus 2. And once you plug in the 0 for the h, sorry, once you plug in the 0 here for the h, notice that you will get 2x minus 2, which is what I got the other way over here. So that's the correct way to use L'Hopital. I wouldn't do this one using L'Hopital. And remember, you don't have to answer every single question. You only answer the questions that you need. This is one of those where I put it on there because some people needed to satisfy standard A1. And so hopefully this helps you see that you know how to do this, and it's just a matter of not thinking that always you have to use L'Hopital. Sometimes you can just use algebra. Okay, I'm gonna stop this video here because it's 10 minutes, and then I'll do 3 and 4 in a separate video.